Good evening, guys. Happy New Year. Today is January 1st, 2021. Hopefully, 2021 will be much better than 2020. And today, I will be performing my first class. And one of the books that I'll be using is Calculus, Early Transcendentals. And the author is Bright and Conrad. In case you guys like to follow, what kind of tools I'm using. Besides my calculus book, I will be also using a graphing calculator, and this is a Casio, and the model is FX9A60G2. Since a graphing calculator is required for these topics. So today, the first topic of this calculus book is function. And right here we have the problem number 13 that says graph each function with a graphing utility using the given window, then state the domain and range of the function. So we have a function which is f of x equal 3x24 minus 10, and we have a window which is from -2 to 2 and from -10 to 15. So let's start building the Cartesian plane. So we have the x-axis. So we have that the x-axis goes from -2 to 2. So we have 1, 2, and we have -1, -2. This is the x-axis. And then we have that we gotta draw the y-axis from -10 to 15. So we have the y-axis we have the window of the y-axis, which is from -10 all the way up to 15. Alright, let's just start plugging numbers into the function to see, and then start drawing the graph. So let's see what happens if x is equal 2. Then we have that f of x, or the function, will be equal to, so let's substitute 2 on the variable x on the function. So we're gonna have 3 factor of 2 to the 4 minus 10. And this is gonna be equal to 3 factor of 2 to the 4, that's 16 minus 10. And this is going to be equal to 3 times 2, 16, that is 48 minus 10. And this will be equal to 48 minus 10, that is 38. So we have that one of the points on the graph will be 2, 38. So if x is 2, then the graph will come up all the way up to 38, which is, we have up to 15, so 38 all the way up. Now let's see what happens if x is equal 1. Then we have that f of x will be equal to 3 times 1 to the 4 minus 10. This will be equals to 3 times 1 to the 4, that is 1 minus 10. That will be equal to 3 times 1, that's 3 minus 10, that is minus 7. So we have that if x is equal 1, y, or f of x, will be minus 7. Minus 7. So this is one of the points in which the graph is going to go through 1 minus 7. Let's see what happens if x is equal to 0. Then we are going to have that f of x will be equal to 3 times 0 to the 4 minus 10. And this will be equal to 3 times 0 to the 4 is 0 minus 10. And this will be equals to 3 times 0, that is 0 minus 10, that is 0 minus 10, that is minus 10. So we have that if x is equal to 0, y is going to be 10. So x equals 0, y is going to be minus 10. Right? So now we have the right side of the graph. Let's plug into the function couple negative numbers, so we see how the graph goes on the left side of the Cartesian plane. Let's see what happens if x is equal minus 1. Then we are going to have that f of x will be equals to 3 times minus 1 to the 4 minus 10. And that will be equals to minus 1 to the 4, that is 1, in other words, 3 times 1 minus 10. And that will be equals to 3 times 1, that is 3, minus 10, that is minus 7. So if x is equal minus 1, f of x or y is going to be equal minus 7. So we have another point on the graph. Minus 1, minus 7. This is another point in the graph. Let's see what happens if x is equal minus 2. Then we have that the function f of x is going to be equals to 3 times minus 2 to the 4 minus 10. This is going to be equals to 3 times minus 2 to the 4, that is 16 minus 10. That is going to be equal to 3 times 16, that's 48, minus 10, that is going to be equals to 48 minus 10, that is 38. So when x is equal minus 2, right, f of x is going to be equal 38 all the way out. So we kind of have a, when x is minus 2, f of x is 38, and when x is 2, f of x is also 38. So the function is going to look like this. But if we would like to see what the function is gonna cut through the x-axis, what we can do is equalize the function to 0 to see which point of the x-axis the functions go through. All right, let's see what happens. So 3 x to the 4 minus 10 equals 0. Let's see in which point the function cuts the x-axis. Okay, so 3x to the 4 minus 10. So we basically gotta isolate the x in order to see what's the value for x. So the first step we gotta do is move minus 10. And minus 10 is subtracting on the left side of the equality. So let's add to this function 10 plus 10 on both sides. Let's see what happens. Then we're gonna have 3x minus 10. Plus 10. Then we're gonna have 3x minus 10 plus 10, we cancel, and we're only gonna have 3x to the 4 equals 0 plus 10, that is 10. So we basically move the 10 up to the right side of the equality. On the left side have negative sign, on the right side is gonna have positive sign. And now the next step is move 3 to the other side of the equality. So in order to move it, we can multiply the entire expression by 1 over 3. And let's see what happens. So 1 over 3 multiplied by 3x to the 4, that's 3 divided by 3, that is 1. We cancel the 3's and we only have as a result x to the 4 on the left side of the equality. Equal 10 times 1, that is 10 divided by 3. So now we have the expression x to the 4 equals 10 divided by 3. But we would like to know how much is the value for x, right? Where on the x-axis the graph goes through. No x to the 4. So in order to isolate x, we can have we can apply a square 4 on both sides of the expression, and then we're gonna have x squared 4 of x to the 4. So that's, we cancel the expression and we only gonna have x is equal to x squared 4 of 10 over 3. And let's see in the calculator what is that numerical number. X squared 4 of 10 divided by 3, and the numerical number is 1.35. So that means that in 1.35 function is gonna cut the x-axis. So we have over here 1.5. So 1.35 is gonna be about here. And since this is a parabola function, this function is also gonna cut on the left side at minus 1.35, which is about the same distance from 0 to the right and left. So the function is gonna come out to all the way here. So this is the function f of x equals to 3x to the 4 minus 10. Alright, but let's focus on the main purpose. The main purpose is to find the domain in the range. But I would also like to show you how the graph is gonna look like. So let me draw the graph in my calculator, and I show you how it's gonna look like in a calculator. So let's see where the graph function is. New graph, menu, graph, and then 3x to the 4 minus 10, and the windows is from minus 2 to 2 and from minus 10 to 15. So here is the graph. I don't know if you guys can see it since I'm making this video at night, but here is the graph. Anyway, so the main purpose is to find the domain, and the domain of this function is, let's analyze the graph and see. I will plot number. Is there any restriction on the x-axis, or can all the numbers be included on the graph? So we see on the graph, I will keep plugging number on the x-axis. The graph is gonna be show more numbers on the y-axis. So the domain of the function is the real numbers, or another representation of the real number is the domain of this function will be from the minus infinite to the infinite. Okay? And now let's find the range of the function. The range of the function. In order to find the range of the function, we gotta see the y-axis. And what is the lowest number on the y-axis? So we see that O is starting minus 10. So the range is from minus 10 all the way up to the infinite. So the range of the function is from minus 10 to the infinite. So that's basically the solution for this problem. We found the domain and the range of this function. Thank you for listening, and I will be posting the next video shortly. Have a great night.